Hello and welcome to Veterinary Epidemiology lecture series. Today we are going to talk about standardization of rates and risks. When we do a study or when we measure the disease occurrence in terms of mortality and morbidity, we calculate an overall value. However, this value is influenced by the specific subgroups which have an impact on the overall values, and these specific groups are called risk factor strata, and each of the risk factor strata have a relative contribution to the overall value. And this kind of groups, which could be breed, age, gender, or management, or feeding, and so on, are called potential confounding factors. To understand better the concept of a confounding factor, let's make an example that in an endemic area where brucellosis is widespread, we could say that a man carrying a staff would be most likely affected by brucellosis. Of course, the staff itself cannot cause the disease, we really know that. But on the other hand, the carrier of the staff, most likely it's a shepherd, and therefore he is exposed to infected animals, and therefore he gets the disease. So in this kind of concept, the staff, it's a confounding factor, and to account for that, we would have to eliminate the role and the association that it has to the risk. And to do that, we use a technique which is called standardization of rates and risks. If we know the potential confounder has categorical nature, an adjustment can be made to the crude rate, so to the overall value of the morbidity or mortality, by applying different weighting to this for each of the strata that we have identified as potential confounding factor. And this whole process is called standardization. In general, crude values can be used only to compare two populations which are quite identical in terms of all their risk factors. But however, this is rarely the case in reality, because different farm to farm or region to region, there are different breeds, different management styles and influencing the disease. Therefore, we need a technique like standardization to discriminate this kind of effects between the two populations which we would like to compare. And the difference between the crude rates and the standardized rate is that crude rates are calculated based on the population which we are studying directly. Meanwhile, the standardized rates use another population which is called standard population as reference to be accounted in order to find the differences between the groups. In terms of standardization, there are two main types of standardizing. There is the direct standardization and indirect standardization. These methods are relevant. There are differences, expected differences between the stratum-specific rates into the population. And as we said, these stratum-specific rates have a contribution to the overall rate, and knowing and discriminating between them would give a more comparable value because we eliminate their role in that. In the both methods, use values from a standard or reference population which they refer to in order to account the differences between the stratum-specific rates. And the standard population in itself could be data from a census, so demographic published data. There could be used the total of the sampled animals under study, so the study population, or one of the two groups which are compared can be chosen as the standard population. When we talk about direct standardization, the principle is based that we do know the stratum-specific rate, and that's the distinction, because we know that we start the discussion from the population of interest, and we have the specific stratum for sexes. We know how many sick males and we know how many sick females. And then we compare this to the total percentage of males and females, let's say, into the overall population. And we know that from demographic data how many are males and how many are females. And then after we weight the specific rates via the standard population values, we can compare the standard adjusted values. The direct standardization, as we said, is weighting the specific rates by the factor distribution in the general population. And therefore, first of all, we have to calculate the stratum-specific rates and then choose a standard reference population and derive the specific distribution of the factor into the standard population, and then multiply the stratum-specific rates by the value of the factor group. The direct standardized risk or rates is obtained by summing the products across the strata, so summing the product between strata and the factor. However, we have to know that this kind of technique is used only when we have large samples and cannot be used when small sample sizes are available. The weighting process is based on a formula that says that the specific value into a strata is multiplied by the frequency of the factor above the total population plus the other strata, specific rate of the other strata, which is multiplied by the frequency of the factor above the standard population. We could have more than two strata, of course, depends by the nature of the risk factor or the confounding factor we are studying. To make it more clear, let's take an example of tuberculosis in two different regions of Georgia. And we are taking the Imereti and the Kakheti region in Georgia to compare the occurrence of tuberculosis in cattle. We assume that the disease is affected by the breed type of the cattle, and we selected beef and dairy animals to be compared. We collect the data and we summarize the data into a table. And the table, as you can see, it has the regions, the Kakheti and Imereti. Then it's the type, which is beef and dairy animals. Then we have the total animals which we sampled, the TB testing, and we found out that there are 17 positive beef animals in Kakheti and 41 dairy. And then we had 10 beef animals and 120 dairy animals positive in Imereti. If we see the specific rates and the crude rates, we would see a difference, because if we check the specific rates in Kakheti, we would say that we have 3% of beef and 9% of animals sick in dairy. If compared with Imereti, we would see that these values are higher than the Imereti, and there are 2% in Imereti of beef and there are 8% of infected animals in dairy. And if we compare these specific rates to the overall rate, which is the sum of deaths into a region above the sum of animals in that region, we see that the crude rates shows us that in Kakheti the disease is lower than in Imereti, which is 5.8% against 6.5%. But the specific values are higher for Kakheti and lower for Imereti. So to account for this discrepancy, we know that from the overall population of Georgia, there are about 40% animals of beef and there are 60% animals of dairy. And we assign them into the weighting column. To find the adjusted value for Kakheti, we would say that 3% times 40% of beef animals plus the 9% times 60% of dairy animals would lead to 6.7% overall prevalence in Kakheti. The same we apply also for Imereti, and then we know that 2% times 40% of beef plus the 8% times 60% of dairy animals would lead to an overall standardized rate of 6%. And we see now that if we compare the adjusted rate, we see that the Kakheti has a higher level of disease occurrence in comparison with Imereti. So the standardization showed up true nature of the disease into these two regions. And this was the technique using census data that we know from the overall population, what the distribution of beef and of dairy animals in the total population. Another way to do a standardization is by using total of the sampled animals. And as we said, it always has to be a large sample size, so will be fair enough in calculating the standardized rates. And in order to define the weighting for this kind of calculation, we have to sum up the total number of animals, which in this case is 3,000 animals for both regions. And then we know that for beef animals, we have 1,050, and for dairy, we have 1,950. We divide both of these by 3,000, which is the total population, and we get that the distribution of beef in our sample is 35%, and the dairy distribution is 65%. We apply the same concept by summing the products between the stratum specific rates and the weighting, and we find out that the Kahetty overall rate of the disease is 7% against the Imereti, which is 5.9. Again, this is showing that higher in Kahetty and lower in Imereti. Another method is direct standardization by using one of the two populations as a standard population. And in this case, we don't calculate the weights, but we find the expected number based on the specific rates of the chosen standard population. Let's say that the reference population in this scenario is the Kahetty. So we have in Kahetty in total 1,000 animals, which are 550 beef and 450 dairy. In order to find the expected number of animals sick, we would say that the specific rates multiplied by the number of animals by type in Kahetty region. But we choose the specific rate of Imereti because we want to compare Imereti to Kahetty. Therefore, we would have 2%, which is the rate of TB in Imereti beef cattle, times 550, which is the beef population sampled in Kahetty, plus 8% of dairy infected animals in Imereti, times 450 animals of dairy type in Kahetty. And then we find that the expected number for this rate would be 47. We divide the 47 by 1,000, and we find that the adjusted rate for Imereti is 4.7%, which compared with the unadjusted rate, which was 6.5, is much lower, and compared now with the crude rate of Imereti, it's again lower. So this is showing that Imereti has a lower rate than the Kahetty region. The same principle can be by switching the reference population and saying that now we define as reference the Imereti instead of Kahetty. And we find out that the adjusted rate for Kahetty is higher than the crude rate, which is 7.6 in this case compared to 5.8. And if we compare the 7.6 in adjusted rate to the crude rate of Imereti, we find out again that Kahetty has a higher rate of TB in comparison to Imereti. Another way to do standardization is indirect standardization. Usually the indirect standardization is used when we have a very small sample sizes or when we don't know the stratum specific values. And therefore, for these reasons, we don't start by the population of interest, but we start by knowing the disease prevalence or incidence or mortality by each of the strata of the general population, and then we get these values to the overall value of the population of interest and compare the standardized rates of population of interest, and then we find out the adjusted rates. For indirect standardization, it's necessary to know the rate of the affected animals in each stratum of the overall population. It's not needed to know by stratum in the study group or the interest population, but we have to know the overall value in the interest population. In order to calculate the indirect standardization of rates and risks, we have to find out the expected value or the expected numbers. And the expected numbers is the specific value of the stratum in the reference population, which multiplies the frequency of the characteristic in the study population or the sample population above the total number of the study population. This is in comparison with the direct standardization is that we started from stratum specific of the interest population and not the reference population. In this case, we use the stratum specific rate into the general population, into the reference population, and then multiply this by the study population frequency above the total number of the study population. And this is done by summing all the strata. In order to calculate the indirect standardized rates, we would need first to estimate the expected number of infected animals by stratum in the interest population. And to do so, we calculate this by having the specific value of the infection in each of the stratum of the reference population, which could be the country population or so on, depending by us which we select, multiplying by the frequency of the characteristic in the study population above the total number of the sampled study population. And as a first step after defining the expected numbers, we would go to find out the standardized mortality or morbidity rate, which is called SMR. And this is the ratio of the observed number of sick or dead animals above the expected number of sick or dead animals. The expected number we firstly calculated and the observed number we have estimated during our survey. And then to find the adjusted rates, we would have the SMR multiplied by the crude rates. We take again the same example between Imereti and Kakheti TB in Georgia. We collect the data and we lay the data out in the table. From a nationwide survey, the information that the standard rates of the reference population are that 2.5% of TB is present in beef cattle and 8.5% is present in dairy cattle. And the overall disease occurrence in the national flock is 5.2%. And these are the rates which we use from the reference population. We don't know and we don't have information about the number of sick animals by stratum, and therefore we don't know the specific value of the stratums. But we do calculate only the crude values. And then, as we said, we first calculate the expected number of cases, then we do the standardized mortality or morbidity ratio, and then we adjust the rates. And all of these figures are laid out in the table. But let's see how we did calculate such figures. For the expected value of sick animals based on the reference population data, we find out that 2.5% of the beef cattle, which was the national rate, times 550 beef cattle in Kakheti, plus 8.5% of the bee in dairy cattle times 450 beef cattle in Kakheti, would lead us to have 52 expected cases in Kakheti based on the reference value we got from the national population. We do the same for Imereti, and then we find out that we have 140 to be expected in Imereti. After we got these values, we calculate the SMR, so the standardized morbidity ratio, and we have the observed, what we measured in the study, above the expected numbers that we just calculated. From the study, we had for Kakheti 58 animals in total, which proved to be positive, above 52, which was expected to get into the region, and then we get an SMR of 1.11. For Imereti, we got 120 positive animals, and then we had 140 expected. and therefore we got 0.85 the SMR for Imereti. Since we have calculated the SMR for both of the regions, and we do know from the study the crude rates, we could calculate the indirect adjusted rates for both of the regions, and therefore we can have 1.11 timing 5.2% of crude rate in Kakheti equals to 6.4% as adjusted rate for Kakheti. And then for Imereti, we would have 0.85 the SMR times the 6.5% of overall or crude rate would lead and equals to 5.5% in Imereti. So we can see again that even through the indirect adjustment, we find out that the Kakheti has a higher infection in comparison with Imereti. And that's how we do also the indirect standardization. As final note, I would like to say that with all the different methods we calculated the adjusted rate, the figures didn't sum up equal by different methods because each method is dependent by the choice of the standard population or the reference population. Therefore, this is a bit arbitrary. And many epidemiologists, when possible, do show only the stratum-specific rates and don't account with the process of standardization. However, standardization is very useful, so I'm not discouraging you to use standardization because it's a very useful method to compare two different populations. And if we need to do these comparisons, of course, standardization is the first choice, but there are also other methods, especially when we want to compare about the confounding factors more, is the multivariate analysis techniques used quite often, and Mantel and Hensel technique, and then it's also the logistic regression, which accounts for stratification purposes. And these are techniques that we will talk into another lecture series, and till then, be safe and see you next time.